Hello, and welcome to today's Tech Talk session. My name is Eddie Ambler, and my co-host is.
And I'm Leo Alvarado.
Today, we have a great agenda. We always are being asked, hey, can you guys help us to understand where the Oracle Cloud Database Services fit into the ecosystem? How does it size up to the competition? So today, we've developed an agenda to have just that discussion. We'll have a very brief overview of our Oracle Database Cloud Services so that everyone understands what our offerings are. Then we'll start to tackle the topic of the conversation by going over the Oracle Database Cloud Services and features that are really geared for making small and mid-sized workload affordable and easy to use on our cloud. We'll follow that up with, having a conversation around what are some of the pitfalls around single instance compute, storage scaling, consolidation limits that you might face trying to run Oracle databases on third-party cloud solutions. And then we'll be very specific and look at how the Oracle database cloud pricing really gives you more for less. So as a salesperson, you'll be assured that you can give your customer the very best service that gives them just what they need. As a customer, you can be assured that you're maximizing your CapEx and OpEx dollars to deliver the best solution to your business. So we'll take a quick glance at how you can use co-managed solutions on one of our Oracle database PaaSes in the cloud, or if you need a fully managed database service, we'll talk about how we deliver DBaaS and how it compares to the industry as well. All right, let's get going. First question, do you know that Oracle offers multiple databases deployment models? The Oracle database is 100% compatible across all the deployment models. It doesn't matter if you're deploying the database on-premise in a hybrid cloud scenario, where you might have part of the database on-premise and applications in the cloud or vice versa, or everything fully in the public cloud. It's the same Oracle database engine that runs everywhere, right? Again, on-premise, on commodity, on engineered systems, and behind your firewall in our cloud customer, in containerized solutions, in third-party clouds. And obviously, you can run in the public cloud on our Exadata cloud infrastructure as well. So that brings us kind of to the next question that usually gets asked. Did you know that Oracle offers different management models? So we talked about deployment. What do I mean by management models? Well, when you think of IaaS, infrastructure as a service, what your vendor is giving you is the infrastructure up to the hypervisor. Then you're responsible for everything that goes onto that VM, the management of it, the patching of it. Literally, they're only responsible for the physical hardware and that VM up to the hypervisor. In a co-managed model, Oracle manages the infrastructure up to the hypervisor as well, but that environment is being laid down with database tooling to give you cloud automation, which we will go over a little bit later on. And then we also have what we call a fully managed. In that case, Oracle isn't just providing you with the VM, with the cloud automation, with the database software installation, but they're also managing the management and the patching of that database environment. And you, the customer, you only worry about managing your data itself. So did you know what cloud services Oracle offers for its Oracle databases? In our public cloud, we have 3 database services that we offer. For our customers who are looking for the easiest lift and shift of the Oracle database that's on-premise, not running on Exadata, we offer our base database service, which runs that same Oracle database in a VM with cloud automation tied to it. It has the ability to give you single instance and 2-node rack, and it scales pretty well too. It scales all the way up to 80 terabytes of data and 128 cores of processing power. And where that isn't enough, maybe you need more scale, maybe you need more performance. This is where we have brought our Exadata platform to the cloud, and we run it on one of our 2 other services you see here on the screen, the Exadata database service on dedicated infrastructure in the public cloud, or on our autonomous database, which runs on the Exadata cloud platform as well on shared or dedicated Exadata infrastructure. So you say, well, what's autonomous? So I mentioned earlier, there's a couple of management models that you can take. The Exadata database service and the base database service, they use that co-managed approach where Oracle manages the infrastructure and they deploy the database software and give you the automation to manage that environment. Whereas autonomous database takes it a step further, managing even the database environment, leaving you only to have to manage the data layer. There's lots of other really cool tools, which we'll get into, and value propositions for the autonomous database. But there's actually another tech talk we're going to do that drills into the value of autonomous database. But for today's session, just be aware that the autonomous database, whether it's on shared or dedicated, is delivering a fully managed service for you. The other really cool thing to note here is that there's no minimum term in public cloud. You can spin up any one of these databases, use it temporarily, and spin them down. Therefore, you only pay for what you use. For those customers who really can't go to the public cloud, you need to have your data in your data center, either because of latency or regulatory compliance reasons. We offer Exadata database services as well there, similar to what you see in the public cloud. We have the co-managed model with the Exadata database service on Cloud at Customer, and we have the fully managed model with the autonomous database on Exadata Cloud at Customer. So why do I want to go to cloud? Are cloud offerings cost efficient? Well, that's a great question. So one of the things that really makes the cloud beneficial to businesses is its agility, right? It's the elasticity that it provides. The elasticity and agility that it has reduces licensing costs by allowing you to adjust the CPUs to align with the workload demand. Therefore, you only pay for the OCPUs that you need to deliver the business. So how about your choice of license included and bring your own license models? This is also something that the cloud delivers to you, because we understand that we have customers who've made lots of investments in Oracle over the years. So we want to make sure that their journey to the cloud rewards them for being loyal customers. But at the same time, we have a great license included a model for our new customers so that it's financially beneficial for them to be able to move to the cloud and use all of our database features and options. So let's take a quick look at these two choices. On the left, you see license included, which is ideal for organizations that are seeking to build new applications or expand functionality. It includes the Oracle database, options, management packs, all at one low price. It's pay-per-use pricing for the OCPUs, and it can all be paid for using universal credits. Therefore, no longer do you have to be worrying about how many units of each individual database option do you need. You can simply create an OpEx budget and to buy your universal credits and apply them across any of the cloud technology items that you need to run your business. Okay, on the right side, we have bring your own licenses. Again, ideal for organizations that are moving existing workloads to the cloud. A very good choice for applications that have steady state workloads as well. Often, even if you have licenses, we see folks that have dynamic workloads with lots of sways and peaks take advantage of license included to even further drive down their cost. So an interesting thing about bring your own license is that it actually comes with quite a few included services that you would otherwise have to pay for on-premise, such as transparent data encryption, data safe, diag and tuning packs, and real application testing, all at no additional cost. So, when I talked about our base database service, it has the ability to use one of 4 licensing tier bundles that Oracle has established in the cloud. With Standard Edition and all of our database services, you will get transparent data encryption included at no additional cost. And this is because Oracle takes security very serious, and we want to protect the data at all layers of our database services. So you're also able to leverage our multi-tenant with up to 3 PDBs at this tier. And always, you can take advantage of technology such as machine learning, spatial, and graph. We also have the Enterprise Edition, which enables you to be able to do data guard, real application testing, take advantage of data masking and subsetting, and again, tuning and diagnostic packs. The Enterprise Edition High Performance group, this is where it brings in partitioning, multi-tenant, advanced compression, advanced security, and the cloud management packs. And lastly, we have the Enterprise Edition Extreme Performance. This brings in active data guard, real application clusters, application continuity, database and memory. This is the edition that the Exadata database services uses. And if you're using base database service with the rack mode, then this is also the version that it will use there.
Eddie, if I do the BYOL, do I have to bring all these licenses?
Well, great question, Leo. It was like I was mentioning just a few minutes ago. When you move to the cloud, there's going to be a set of licenses, if you already own them, that you don't need to bring, such as if you own encryption and you're moving to the cloud, encryption's included in the offering. If you own DIAG and tuning, right, which most customers with Enterprise Edition databases, they want to be able to monitor, they want to be able to take advantage of the ADDM utilities and the tuning utilities. So they have the DIAG and tuning. So all of those licenses are included for you to use when you bring your Enterprise Edition license over as a BYOL. So thanks for the question. So the next question that was out there, Oracle Database Cloud Services has features that makes the Oracle DB affordable for small and mid-sized workloads. We've always talked about the Oracle database, right, for mission critical and big. And we are continuing to really maximize that footprint. But cloud has really also all of a sudden opened the doors for smaller customers to be able to take advantage of the same performance and scale and rich set of features for workloads that otherwise might not have been able to do that. So, what do I mean? Well, we actually have free Oracle databases for developers. In our Oracle Always Free tier, you can find a copy of the Oracle Always Free Autonomous Database, which you can use directly in our public cloud. And we also have the Oracle Autonomous Database free container image, which you can download and run locally on your laptops. But we also have the Oracle Database Free, which is available as an RPM that you can download or a VirtualBox VM image. So you might be saying, tell me a little bit more about the Autonomous Database Always Free tier. So let's take a look at that and see what that really contains. So the Autonomous Database Always Free is an autonomous database offering that's in the Always Free tenancy. You get 2 instances of the autonomous database. You can use these databases for everything from transaction processing, analytics and data warehousing, JSON application, Apex applications, and each Always Free autonomous database instance is deployed on shared Exadata infrastructure and includes 1 Oracle CPU processor, 20 gigabytes of database storage, and support for 20 maximum simultaneous database sessions. Note this, the Always Free autonomous databases can be upgraded to a paid instance after provisioning to enable features like storage or CPU scaling. So you can start off with the free autonomous database version, and once you fall in love with it, you don't have to go and recreate your database. You can simply upgrade it to a paid instance. So let's keep going down the track. So we've talked about the free services here, and what about base database? How does this fall into the conversation of addressing affordable, small, mid-sized workloads? Well, the base database has the ability to run single instance standard edition. So if you're on premise and you're using Oracle databases with standard edition, this is a great way to get into the cloud and use your existing licenses or even spin up new versions. So in the cloud, we are able to support standard edition and enterprise edition on our base database service. Again, you get root access to be able to customize your database environment the way you want it. You have access to all the supported features and options that are in the edition that you choose. And you have access to user-controlled cloud automation, right? And it's that cloud automation that really brings a lot of value and agility, cutting down on the operational time and simplifying some very complex tasks. And you can do it all from a few clicks in the console or through the REST APIs. So what do you get? On the base database, you can scale from 1 OCPU to 8 OCPUs, right? And I mentioned the fact that it can scale from 256 gigabytes to 80 terabytes. So you get a good amount of scale available. So the one thing with the standard edition is that it is limited just like on-premise, to 8 OCPUs in your deployment. Okay, so how can I reduce costs using this? Again, because you only have to allocate one OCPU in this model, and you have the ability to elastically grow and shrink the CPUs, you can maintain your costs. And again, this is user-initiated compute scaling that really allows you to align your costs and your workload demands. Okay, and you have the choice of both licensing models. Again, you can use bring your own license or license included. Because it's the same Oracle database, it makes an easy lift and shift from on-premise to the cloud. Well, what about Enterprise Edition, right? Because I mentioned that. So what's really different here? Well, whereas Standard Edition was limited to a single node and 8 OCPUs, the Enterprise Edition is able to scale to 128 OCPUs across 2 nodes and actually leverage rack technology to give you the kind of HA that you might want to deliver for your certain applications. And just like the Standard Edition model, the Enterprise Edition is also able to scale to 80 terabytes, also able to initiate the compute scaling, just like the Standard Edition, and has the same choice of license included or bring your own license licensing. So let's take a look at how this is built. From the UI console, we simply click on Oracle Database, click on Oracle Base Database Service, which will launch our Create Database, give it a name, configure how many nodes we want, configure the database edition that we want, and add our SSH keys, and define the type of license we want, and create database. Bang, you've done it. So we're moving along. The next area that we're going to talk about is Autonomous Database Serverless. So we've talked about our base database, and we've talked about the things that were free, but let's talk about Autonomous Database Serverless, because I think that this is really one of those really great extensions to the Autonomous Database family that really allows small and mid-sized databases to operate efficiently and at a low cost. So lots of operational value as well as cost value in this technology. So the Autonomous Database subscription has 2 main flavors. There's autonomous transaction processing, which is good for OLTP and mixed workloads. And it has another flavor of the autonomous data warehouse, which is pre-configured for data warehousing solutions. It's the same autonomous database, able to do both of these types of workloads. And I'll introduce you also to a new concept that you'll start to hear and see as you use the service, which is eCPU. So most of us are used to the concept of OCPU, right? So the map to remember is that 1 OCPU is equal to 4 eCPUs. What's the biggest value that jumps to me is that this is the mechanism that allows us to deliver fractional OCPUs. So for those customers who might be using other technologies that use the concept of vCPU, I've kind of mapped out the license here. So if you're using Enterprise Edition, 1 processor license is equal to 2 OCPUs or 4 vCPUs. And as I just showed you, to get to eCPUs, you multiply by 2 there. So it's equal to 8 eCPUs.
Eddie, I see some question here. Like they're asking, can they still use OCPU with autonomous database?
Great question. So the autonomous database is starting to migrate to eCPU. And an important thing to note is although the services today continue to allow you to choose OCPU and eCPU, there are some features and functions that are net new that are only being deployed with eCPU. Matter of fact, if you go out and try to use the calculator to do sizing, you probably would have noticed recently that the ability to do sizing from the cloud calculator using OCPUs has been turned off. So the direction for an autonomous database is eCPU, but in the short term, yes, Leo, you can adjust, and I will show you in some of our demos between OCPU and eCPU. We're encouraging everyone to start moving to eCPU. Again, it's beneficial to you because you can actually allocate smaller allocations of CPU to your workloads. And it's also advantageous to your pricing, right? That way you pay for just what you need, and that's the kind of efficiency that you want. And when we're talking about small workloads, there's nothing better than being able to grow in smaller increments of one eCPU versus a whole OCPU at a time.
So Eddie, if they're deploying their database with eCPU, what's the minimum?
Well, that's going to depend. So on a standalone autonomous database using eCPU, you need two eCPUs. So which that's half of one of the OCPUs, right? Based on the ratio. But we'll talk about this concept of a resource pool, which lowers that down to one eCPU. So basically, 25% of an OCPU is the minimum as you start to move towards some of the eCPUs. So that's what I'm saying is, it's financially beneficial for small and mid-sized workloads. It's financially beneficial for consolidation workloads to utilize eCPU and to really look at the features of autonomous database to not only simplify operational tasks, but to really help to lower the cost of delivering the services as a side benefit of getting increased agility and more modern application functions. So let's talk about the autonomous database serverless just a little bit more because I wanted to make sure that everyone kind of had an opportunity. So the autonomous database provides an easy to use, fully autonomous database that scales elastically, right? It delivers fast query performance, requires no database administration. With autonomous database serverless, you do not need to configure or manage any hardware or install any software. You simply just pick your desired CPU, the amount of storage, and where you want your database to be deployed. The autonomous database handles the provisioning of the database. It handles backing up the database, patching and upgrading the database, and growing or shrinking the database resources as the workload mandates. So we talked about this a little bit, is that the autonomous database is good for both transactional and analytic workloads, right? So no need to have multiple technologies. Just deploy the pre-configured version of the autonomous database for the workload type you want to service, and it's done with just a few clicks. So many of us have seen the IDC white papers over time that have talked about Exadata initially, and then now I've talked about the value of autonomous database and how that has impacted the IT staff. So autonomous database has truly lowered IT staff costs by totally automating tasks that used to take a considerable amount of manpower to do to maintain the infrastructure, to maintain the database software stack. All of that now with autonomous database is included in the stack so that the IT staff can spend that time working on delivering business functions and value directly back to the line of business. The elasticity that is available in the cloud actually helps to lower licensing as well, right? We talked about being able to elastically align the enabled CPU that you're paying for to the workload demand, and that the fact that the autonomous database does this automatically. Okay, you're not having to understand it, learn it. The system will do that on its own. But that's not the only thing that's lowering licensing costs there. You have the fact that in the cloud, there are license features that we talked about that you otherwise would have needed to pay for on premise, which no longer have to be in your budget because they're included in the service. So taking full advantage of those things really helps to not only give you the performance of a fully managed system that happens to run on the Exadata database platform, so you get that performance and scale that is industry tested, because we're totally tied in from end to end into the infrastructure, into the monitoring system. We are able to detect more incidents before customers can even find them. And you can see that the ADB detects 88% of the incidents that we are logging and tracking before the customer. So that's a great value. So you're getting a more robust system, one that has more operational efficiency, better licensing cost, more modern application functions and tools, and got a better uptime with an SLAs that are attached that you can read about in the product documentation. So I mentioned autonomous database and consolidation. And the thing that enables you to be able to do the consolidation with autonomous database is called elastic resource pools. So I want to take a minute to walk you through that, because elastic resource pools takes your minimum standalone eCPU deployment of 2 and cuts it in half to 1, further allowing you to have oversubscription and fractional eCPU realization. Okay, customers are charged only for the usage of the pool rather than the usage of each individual database, right? So just because you created your database and you allocated 2 CPUs to it, if your database wasn't running or wasn't using the 2 CPUs, then you would only pay for the portion that was used. So it's utilization based versus allocation based. Now, when you define a pool size, right, for your consolidation, which we'll outline a little bit more with pictures here, you'll be able to actually deploy databases with allocated CPUs that are up to 4 times your pool size. So this way you pay for the active eCPU in the pool, regardless of how many autonomous databases are deployed. The available pool sizes range from 128 all the way up to 4,096. You can scale your individual database eCPUs up or down as you need, right? So if you have a database in the pool and one of them needs more CPU, not a problem. Go in there and scale it up. Because what we're doing is we're counting the utilization of all the CPUs for all the databases in the pool, not the allocated CPUs for any individual one. The allocation only counts towards the max deployed to make sure that they do not go above 4 times the pool size. You can add or remove databases from your pool as you need to, right? This gives you 4x to 8x cost savings over standalone deployments. What this means is it's a benefit of up to 87% cost savings versus standalone cloud deployments. And this is especially useful if you today have clusters that are using some type of virtualization to deliver oversubscribed database systems. You're a customer that has a large number of small databases, maybe microservices architectures. You're a SaaS provider that has lots of databases, or you have lots of periodically used databases such as dev, test, and QA.
So Eddie, what are some of the drivers or factors that contribute in achieving this savings?
Well, I was mentioning it earlier, right? Is you have the ability to deploy a smaller unit of CPU allocation with eCPUs. So that's one thing. The fact that the minimum per database is less allows you to also have a smaller bill. The ability to elastically scale your CPUs up or down within the pool for individual databases also lets you, adjust your workloads. And then the efficiencies of Exadata. If you're not on Exadata and you then consolidate onto a platform like that, the Exadata has hundreds of CPUs available in the storage servers that also do work on its behalf. So it's the ecosystem of the platform underneath it, along with cloud elasticity and operational excellence that helps to drive these cost savings. And I will show you pictorially a sample workload that shows you how the benefits come. So let's do that. So from a cost comparison, let's say you have a farm of databases, 512 of them, and you're going to deploy them as autonomous databases without resource pools, right? So each of these databases would need the minimum 2 eCPUs to be standalone, which would net you 1,024 eCPUs that you would be billed for. Well, what does it look like with Elastic Resource Pool? So in this case, our minimum to deploy an autonomous database is 1 eCPU. So we could define a pool size of 128 eCPUs and still deploy all 512 databases with 1 eCPU each. How can I do that? Because remember that the pool size allows up to 4 times the number of eCPUs allocated to it. Okay, so in this scenario, if only 25% of your databases are running at any one point in time, then you would only be using 128 eCPUs, and that's what you would be billed for. So you can see that the difference between being billed for 128 eCPUs or versus 1,024 CPUs on the left, will generate the 87% cost savings that we were talking about. So this is above and beyond anything that you would get out of the efficiencies of the platform. Underneath it, this is just directly using the benefits of cloud automation, cloud features, and from the autonomous database, specifically the Elastic Resource Pool. So let's look at this a little bit more with a billing example, right? We talked about the fact that the billing levels are up to 4 times the pool size. So assume you have a pool size of 120 eCPUs, and the chart below is the workload over a day that we are looking at. So from 1 a.m. to 7 a.m. on the chart, you can see that our peak CPU utilization in the pool stays under 128 eCPUs. So for that reason, you pay the bill for 128 eCPUs. Between the hours of 7 and 8 a.m., the pool utilization is 192 eCPUs. In this scenario, you're above the 128 eCPU threshold, so you fall into the next tier of billing, which bills you at 256 eCPUs. As the day goes on, the workload continues to rise. You get up to 256, so that between 8 and 9, so you pay 256. But at 9 to 10, the workload really spikes up, and now you're using 320 eCPUs. This kicks you into the next tier of billing at 512. But notice that all of these numbers are cheaper than the 1,024 of running it as standalone databases. So as the day goes on, the workloads continue to hit its peak at 11 a.m. But then at 11 to 12, people start going to lunch, workload starts to fall. And you see the peak is now 448 eCPUs. But because you're still over 256, you're still at the 512 mark. But by the time lunch really gets into swing, the workload demand is 256 eCPUs. So the hourly bill again falls back down to the 256 tier. So what I wanted to show you there is that throughout the day, right, your workload is being billed to align with your demand. So you are getting to maximize your savings because of the billing model. And again, when databases aren't used, then their CPUs don't count against your bill. So this is a very great way to do consolidation. So let's look at how to create an autonomous database serverless with resource pool. So you've seen the console before, no different. Click Oracle Database, click on the autonomous database, then click on Create Autonomous Database. And this will launch the Create Autonomous Database screen where we're going to choose our first autonomous database to be transaction processing. Well, why not data warehouse? Well, because I want to be able to create an elastic resource pool. The type of database that it needs to be is an autonomous database transaction processing. So then we'll say that it's a serverless type. We'll configure the database, taking note that it cannot be set to 1 eCPU, right? It's showing you here in the screen that the minimum is 2 eCPUs. And that's, again, because we haven't told it that this is going to use elastic resource pools. So we go ahead and define the amount of storage that we want. Notice that we could start our allocation at 20 gigs. And we can define whether or not we want compute auto-scaling or storage auto-scaling to be turned on for a standalone autonomous database. Now, in the advanced options, this is where you'll see the enable resource pool. Once you check that checkbox, what you'll be able to do is choose between joining an existing resource pool or creating a new one. Also notice that as soon as we check that checkbox, we can actually set the eCPU count to 1. That was the reason I wanted to show you that error in the screen for the standalone, right? So this is the value. I've already cut my minimum cost for deploying this database in half simply by enabling it in the resource pool. Okay, so because it's our first database, we're going to create a resource pool. Again, we'll pick the pool size that we want. Then we'll be able to define and what kind of backup retention. Again, the autonomous service is doing all the backups, and for you, you're just defining the retention policy that you'd like to have. Okay, you create the administrator credentials. You choose how the network access type that you'd like to have. And then you choose your database license model and your database edition. If you don't like the default, there's a button on the right to allow you to switch both of these items. Okay, so you then provide a notification contact for notifications and announcements, and that's the great thing. Autonomous Database comes pre-configured with notifications and alerts to keep you informed about when Oracle is operating on the infrastructure or on the database software layers, so that you always are in the loop about what's coming and what's occurring and what's completed. Here in the bottom, under the advanced section here, you can do things like define the encryption key that you'd like, what kind of encryption management you'd like to use, Oracle managed, customer managed, and so forth. And then after that, you just click create, and your autonomous database goes off for just a few minutes and comes back with green and says, I'm done. I'm ready for you to use me. All right, so that's how easy it is to create an autonomous database and to create an autonomous database with a resource pool. Because you've created this resource pool, other autonomous databases can now join it. You can have an existing database that you actually pick up, click on the Manage Resource Allocation, and down in the bottom, you see a checkbox to enable resource pool. Click on that, select the pool leader out of one of the resource pools you already created, and just like that, you will be a member of the resource pool that you selected. And you can see there, it's if you want to leave, not a problem. There's a nice, easy link there. Just click the link, and you can get out of that pool and go back to being a standard standalone database. Leo, any questions came in on that, or am I okay to jump into the comparison conversation? Oracle databases, right, in our cloud versus other competitive solutions such as AWS.
Yep, you can proceed.
All right, so let's start first by telling folks what AWS RDS for Oracle is and what AWS RDS Custom for Oracle is. Okay, so AWS has, similar to us, a co-managed offering, which they call AWS RDS Custom for Oracle. It's a single instance system that has up to 64 CPUs, and they use the term of vCPUs, so it's twice that, 128 vCPUs. That's an equivalent way to represent the cores on the system. They have a maximum 64 terabyte elastic block storage that is used to service the data and recovery space that we are used to talking about on the Oracle Cloud. And all deployments for Enterprise Edition require the use of BYOL. So if you're going to use RDS Custom, it is not available for Standard Edition, and you have to use Enterprise Edition, which also requires you to bring your own license. So on top of costs that you might be calculating in the AWS calculators, you must ensure to bring forward the software costs that you will need to bring to enable those licenses. The other option is a fully managed service similar to Autonomous Database, right, where they're managing up to the database stack as well, and you're managing the actual data. The difference is here is that this is fully managed, where the other one is a co-managed solution where you have access to the VM, but it has the same single instance limitations, the same CPU limitations, the same amount of storage that you will become roadblocked on. So no way to really scale the solution beyond what's here. How do the Oracle Cloud Database Services scale compared to other Oracle Database Cloud Provider services? So on our agenda, I said we would kind of talk about those limits. So let's do that. Databases come in small, medium, and big, and sometimes extra large, right? So how do our Oracle Database Cloud Services map to this? As we go through the services, you'll see that the services have an increasing amount of automation as well as an increasing amount of scale and performance. So, at the bottom of the tier here, I'll say that this is where our base database service comes into play, right? It is the exact same Oracle database software. You can just do a lift and shift. You have the exact kind of access, root access to the VM. You can install your third-party agents that you might need to run your operational flows right there on your cloud compute nodes. But then on top of that, you see that this is where the AWS RDS custom maps. But you notice that it's towards the left. It doesn't have as much storage to scale. It is limited to a single instance. It is limited to 64 cores, whereas the base database has got 100 terabytes. It can have 2 nodes. It can have up to 128 cores. And it also supports standard edition and enterprise edition, along with both licensing models, whether it's license included or BYOL. AWS RDS custom is BYOL only for enterprise edition only. So what about other vendors? Does anyone else really have an Oracle database offering that fits in the co-managed layer? And the answer to that's going to be not really. There are some non-Oracle databases, which we'll talk about in our next tech talk, but these databases in other cloud providers, such as Azure and Google, that are trying to offer Oracle, they're literally offering you marketplace images that are running on IaaS. So they will spin up a VM, that image will install the database, but it doesn't have the cloud automation, it doesn't have the continued management. You're responsible for operating it, managing it, for everything on it. So just as you would on premise. So they're just offering you a one-time install via an image in a marketplace. So what happens when we need more power, we need more scale than either one of these services can give us? This is where our Exadata database services come in. As you can see, it gives you a little bit more automation, gives you a whole lot more scale. You're able to scale from 2 terabytes to petabytes of Exadata storage. So whereas you're limited to a small number of terabytes with the AWS solution, for your customers that have big databases, they want to really do IoT. They want to start to moving nearline data for their data lake. These are great solutions that give them that scale, that performance. If you're using Exadata on premise, this is the same Exadata platform in the cloud, so you can transition seamlessly into the cloud, regardless of whether you need to go into our public cloud or use our cloud customer platform, which gives you the same cloud automation, tooling, and pricing in infrastructure that sits behind your firewall in your data center. But what if you are a customer who needs a fully managed service, right? I'm looking for a fully managed database because I want to give that to my team. This is where AWS RDS comes into play, right? It is a fully managed service like we talked about. It has the same size limitations as RDS Custom, but it's a fully managed service that is available for BYOL for Enterprise Edition. And it does have a license included offering for Standard Edition only. But again, what if you need more than the 64 terabytes that's there? This is where the Oracle offering really, really shines. The autonomous database, like I said, runs on the Exadata cloud infrastructure. So it has that same scale and performance that we were talking about with the Exadata database service. And you can get this on autonomous database serverless, which is ADBS on the far left, which we looked at with as small as a 20 gig footprint. And you can get it as autonomous database dedicated with configurations that can be as big as the Exadata platform will allow it. And at the CPU allocation layer, fractional cores at the bottom, and scale as your workload, as your application scale to thousands of vCPUs. And again, just like our base database service, it has the access to use both the license included and the BYOL license model for Standard Edition and Enterprise Edition. So hopefully this model here really helps you to visualize what our Oracle database services are, where they fit in terms of small, medium, and big, and how they really shine against the competition. So another note is that AWS BYOL requires you to directly license those licenses from Oracle. So you must remember to include that in your cost model. So let's tackle the next question really quick. It says, did you know that you get more capacity and performance for less? So I showed you in our model that you get the capacity. Now we're going to talk about, wait a minute, you're going to tell me that I get that for less with Oracle Database Cloud Services? And that's correct. So let's take a look at customer managed deployments on IaaS. I won't spend too much time here other than to tell you that everyone has IaaS compute, storage, and network so that you can deploy whatever stack you want, whether it's a database, application, combination of both. At all the layers, you'll see that the Oracle IaaS is cheaper than running in the competitive cloud. AWS compute is 2.5 times the cost of OCI compute. The storage is 1.7 times cheaper than AWS. And the area that usually no one really talks about, but it hits the wallet really hard if you don't think about it, is there are lots of data transfer points in AWS network that have fees. Whether you're moving the data back to your data center, it actually has outbound fees, whereas Oracle doesn't charge you for those fees. There's data transfer fees between AZs. There's internet data inbound that's free, but then there's a big cost for outbound. So I'll net out an example so that you can see how with Oracle, we keep it simple. We have a rate card to give you your private connection back to your data center with the security and bandwidth that you prepay for on the rate card. You have a global pricing for outbound through the internet. So big difference, very, very simple touch points so you can plan your costs. So let's look at this cost here. So data out to your data center. If you're using OCI Fast Connect and you have two 10 gig links, your cost is simple. It's $22,338 for it. If you're moving 5 petabytes of data from the cloud to your data center, we don't charge you anything. So what's your cost to move that data? $22,000. Let's look at the same action with an AWS Direct Connect. It's $39,432 for the service, but to move that data back to your own data center, your data, it's $1.2 million of data egress fees, right? So you can quickly see that it's not just the infrastructure that has cost, it's just also moving the data that you have to really be aware of. That's 56 times the OCI cost to move the same amount of data between the Oracle's cloud and your data center versus AWS cloud and the data center. What about data out to the internet? If we move the same 5 petabytes of data outbound to the public internet, it's $508,000 on Oracle. And on AWS, that's over $3 million, which equates to 6 times the OCI cost. So you can see these are not small things to overlook. So as you're doing your calculations, just kind of remember these things here, right? And at the software layer, the AWS BYOL requires you to pay twice the license, and you're getting less functionality. So you can see on the right a list of things that you're not able to get with the AWS RDS offerings. You're not able to get the database vault, flashback database. You're not able to use the messaging gateway. You're definitely not able to use things like real application clusters to give you that local HA and automatic failover between servers in the event that hardware fails. Be able to use tools like real application testing or simplify your auditing and audit trails with unified auditing. There's just a ton of advantages in OCI that we talked about where Oracle includes advanced technologies in the BYOL subscription, right? We talked about the fact that the Exadata has the Exadata storage server software that's included in our offering. It talked about the fact that all of our cloud database offerings include transparent data encryption, the ability to test workloads using real application testing, the ability to keep and safeguard our data. by using data masking and subsetting packs. And it includes diag and tuning, which allows us to easily diagnose and tune our databases. Let's talk about the co-managed services. What I'm going to do here is we had that chart that we looked at that aligned our services on capacity. For that reason, I'm going to compare our base database to AWS RDS Custom. They both give you the same access type to the local VM, but as you can see and saw, the base database had more scale and more storage available to service you. So just for the comparison purposes, I listed the VM shape type that the OCI is using and the AWS VM shape type that is there. So with these two types, I can build a 64 CPU system that can both address 64 terabytes of data and both can have 1 terabyte of RAM so that you end up with equivalent infrastructure. So remember that we were talking about the fact that in the Oracle Cloud, you get more than with on-premise or third-party clouds because the Oracle Cloud Enterprise Edition entitles you to other features. So you see those entitled things that are included with your license marked on the graph in purple. The things are in red are out of scope for the edition. And so let's take a look at this. The entry-level price comparison for the co-managed service looks like this. For the comparison, we have a standard edition 2 database environment configured with 1 core, 16 gigabits of RAM, and 1 terabyte of storage. Oracle's base database service with this configuration can deliver up to 16,000 IOPS and can be licensed as license included or with bring your own license. The comparative solution of RDS Custom for Oracle does not offer the standard edition level of the database engine as a license included or bring your own license option. The standard edition version of the database is only available as a fully managed service on the AWS RDS platform. Let's take a look at how the two services compare for an Enterprise Edition database environment configured with 1 core, 16 gigabytes of RAM, and 1 terabyte of storage. A common cost analysis mistake that is often made is to forget to include the license support fees with the AWS infrastructure and storage costs, which will always exist as AWS does not have a license included offering for the Enterprise Edition database. When comparing the cost to move your on-premise database to the OCI or AWS Database Cloud Service, it is easy to see that AWS's RDS Custom Database Service will cost you up to 176% more than using Oracle's base database service. Note that in our comparison, AWS BYOL includes the license support costs for transparent data encryption and diagnostic and tuning packs, which are included with the OCI BYOL offering. From this viewpoint, you can see that the OCI-based database service provides more storage and compute scale at a lower cost point. Take note of the AWS RDS custom CPU limits. You'll notice that the base database service has 50% more CPU capacity and provides you the option to run a single or 2-node rack database service. Also, note the extreme difference in the IOPS capacity with AWS RDS Custom reaching max IOPS with the IO1 storage at 80,000 IOs per second, while the Oracle-based database service can scale to 640,000 IOPS with a single node and up to 1 million IOPS with a 2-node rack configuration. I wanted to point out the fact that all of the numbers that I've showed and I'm sharing, they are coming from the public calculator. You'll be able to go to the OCI public calculator and put in the inputs that I showed on the screen and I'm displaying here in the model, and you will get that cost. And as far as the database software licenses, we simply use the list pricing and distributed over 60 months and included the support costs in the BYOL model. Okay, as far as the cloud hours, we used 730 hours as our cloud hours, which is consistent with the calculators that are available from Google Cloud and AWS and Azure as well. Okay, so in our storage area, we're able to define how much storage we're going to get, what type of storage it is, and the system will automatically add our virtual performance unit to come up with our cost. So again, we looked at this cost. Remember that we could get our base database deployed with software, license included, for under $200, proving out here with a public calculator as well. Same thing can be done with BYOL. You can go through the process here of filling out the calculation and see that the BYOL costs a little bit more, but for about $310, you can actually do that there as well. Since the OCI Standard Edition and Enterprise Edition base database server use the same BYOL SKU, we can simply update the storage type to higher performance to see that the entry-level cost for an Enterprise Edition database with higher performance storage is about $602. The AWS pricing calculator, right? You'll be able to go to that calculator and simply select RDS custom for Oracle database instances and fill out the information. You can see we use a shape that provides us 2 vCPUs, which is the equivalent of 1 OCPU. We tell it that we want it the Enterprise Edition, single AZ, so that is only one copy of the database, no standby. We tell it the GP2 storage that we want, in this case, 1 terabyte, which we used. At that point, it will spit out our infrastructure costs, and when we add our software BYL costs, you'll see that this solution costs us $1,663 to be able to do this with one core Enterprise Edition. So much more affordable to deploy these types of databases now on Oracle Cloud using the autonomous database technology. This comparative pricing chart, we evaluated a 64-core Enterprise Edition database with 1 terabyte of RAM and 64 terabytes of storage. See that the base database service maintained the same cost savings ratio of 176% over the AWS RDS custom solution as we ramped up to the max size of the RDS custom. Now let's take a look at how OCI's autonomous database serverless, fully managed database service compares to AWS RDS for Oracle, which is also a fully managed database service. Just as we did for the co-managed solutions, we have laid out the specifications of the systems used for comparative infrastructure capacity pricing comparison. One thing to note is that this is not a performant equivalent comparison, as the autonomous database runs on the Exadata cloud infrastructure, which has additional processors in its storage layer that does database work that otherwise would be done at the compute layer. And it also has smart storage technology that helps it to more efficiently conduct database workloads by avoiding unnecessary IOs and data transfer. The following view shows you the BYOL licenses that are included in the comparison of moving your on-premise workload to the OCI fully managed autonomous database or to the fully managed AWS RDS for Oracle solution. In this comparative chart, we compared the cost of a fully managed single-core Enterprise Edition database with 16 gigabytes of RAM and 1 terabyte of storage. From the chart on the screen, you can see that the OCI autonomous database offering provides more scale and cost savings than the AWS RDS for Oracle alternative. Evaluating the total cost of the solutions in this configuration shows that AWS RDS for Oracle cost 143% more than migrating to the OCI Autonomous Database Serverless solution. Note that when licensing the autonomous database with license included model, the savings percent will grow as you use more of the available DB options. In this comparative chart, we compared the same 2 database services configured with 64 cores licensed with BYOL, with 1 terabyte of RAM and 64 terabytes of storage. Note that the capable IOPS of the autonomous database is significantly more than what the AWS GP2 or IO1 storage options can provide. In fact, the AWS RDS GP2 storage with 64 terabytes costs 4.7 times more than the OCI autonomous database storage and only delivers 80,000 IOPS. Also note that at peak capacity, the AWS RDS IO1 storage with 64 terabytes only delivers 256,000 IOPS and costs 20.7 times more than the OCI autonomous database Exadata storage, whose infrastructure can deliver 1.8 million IOPS plus the flash IOPS. Evaluating the total cost in this chart shows that the Oracle Autonomous Database maintains the same cost savings percent of 143% as we ramp up to the max available size of the AWS RDS solution. Here is another viewpoint of the scale and cost advantages that the OCI solutions have over the AWS RDS solution. Note that the OCI Autonomous Database Serverless solution provides more storage, compute scale, and database capabilities at a lower price point versus the AWS RDS for Oracle solution with GP2 and IO1 storage. And that the Autonomous Database Serverless scales to 256 vCPU and 128 terabytes out of the box compared to 128 vCPU and 64 terabyte scale limit of the AWS RDS for Oracle solution. This chart should help you to easily see the scaling and performance limit differences between running Oracle on AWS database services and running the Oracle database on one of the Exadata cloud database services. While RDS is maxed out at 256,000 IOPS and 64 terabytes of storage, the Exadata cloud infrastructure is just getting started. Running the Oracle database on the Oracle Cloud delivers the best performance, the most scale, and the best financial outcome. The elastic compute pricing and autonomous database consolidation features remove the need to settle for less performance and availability in order to try and save on cost. Join us in our next Tech Talk session where we will discuss how cloud economics and the Oracle Database Cloud Services have removed the need to deploy and manage other cloud database platforms to try and save costs. So again, my name is Eddie Ambler, and my co-host is?
I'm Leo Alvarado.
And we will pick up this conversation next month in our next Tech Talk. So I see you next time.